Hello, folks. How are you? I know it's after a very long time, but yes, because I'm doing my MTech studies and job side by side, I got a little less time um for making these videos. But yeah, I came up with a very big playlist now called as the DP, which I think you all are waiting, and I got so many DMs, maybe through LinkedIn's that. Please start with the DP now that we are interested in DP. Okay, so without wasting time, I thought, okay, let's first move with the DP, and then I can cover the graph related problems or tree related problems, which are also equally important, but still people face uh, difficulties solving DP related problems. So I'll try my level best to make you feel at the end of this playlist that okay, now DP is very easy for us. At least we can think and we can reach until a certain step in the DP. I could not guarantee you, like, okay, I didn't want to flaw that, okay, you'll be able to solve it via this. No, but at least you'll be able to solve until certain point. Okay, I'll give you the templates, okay, so that you can follow the template and at least you can reach to the middle of the step. After that, you just need to think a little bit of the intuitions from the question asked to you, and then you can solve it. But DP or dynamic programming is a very important topic which could be asked in your coding tests, in your interviews, also, of course, for sure. And there are so many types of DP. I'm starting this playlist with the linear DP, but I could make another playlist for interval DP, and another for knapsack DP, and something for DP with bit masks, and then something for DP with trees. As and when we go higher with the playlist, the difficulty of the questions will go higher. Okay, so without just wasting the time, let me start with the DP. I hope you all have an idea about DP, like how to use, when to use, what to do, what not to do, how to solve. But still, just for a couple of minutes, for 5 6 minutes, maybe I could start with the things like, okay, when to use DP, how to use DP. You can skip if you already knew this. Okay, so let me try for my beginner friendly people. Like, okay, what is TP? Okay, so the first and the foremost question is like, what is TP? Okay, so DP is nothing but a method or a technique to solve complex problems. So I could say a method to solve complex problems by breaking them down into simpler subproblems. Okay, by breaking them down into simpler subproblems. Simple example I could give is like, okay, let's say you have to make a complex query with so many joins, inner joins, outer joins, and this and that, and all that stuff. What you can do is you can start with simple queries, simple SQL queries, like, okay, I want to collect a data of the ID and name and country from this table, and then I have to collect some country code and postal code and address from some another table, and then I need to collect the university name and college name or something from third table, and then I have to collect them. So initially I'll make a query of the first, a query of the second, a query of the third, and then I'll think of merging them. So this is a similar kind of scenario. Like, you have a complex problems, but you didn't know how to solve these complex problems. So what you'll do, you'll break them down into simpler subproblems, and then you'll finally be able to solve the complex problems. So what it does, it solves each subproblem. It solves each subproblem only once. Okay, and stores its results. Okay, so it will start by solving each subproblems only once, and it stores its results. Now, why is the storing is important? So uh, core of the DP lies over here. Like we already learned in the recursion and backtracking video in the last playlists, that let's say for the particular thing we need to find, let's say I'll give you a simple example of, uh, you need to find a Fibonacci series. Okay, let's consider with this example only, a Fibonacci series only. Okay, you know that this place is 0, this place is 1, okay, and then this place is also 1, and then again 1 plus 1 2, and then 2 plus 1 3, then 3 plus 2 5, and it goes on, goes on, goes on until n points. Okay, so now what you do, let's say you need to find the sixth Fibonacci number, then what you'll do, you'll find the fifth, you'll find the fourth Fibonacci number. Okay, again for fifth you need to find fourth and third, and you need to add those. For fourth also you need to find third and second, and you need to add those. Okay, for fourth again you need to find the third and second, and you need to add those. Now you know only for the 0 and 1. Okay, you didn't know for the sixth index what should be. Again for third, what you can do is you can do second, first, and you can add those. Now you could see that I need to find fourth twice. I need to find third one, two, three times. Literally, I need to find the third Fibonacci number three times. And it again depends on second and first. So I need to find second also twice, no, thrice, three times. First also, it could be 2 and 1 here, it could be 1 and 0 here, so it could also be three times. Multiple times, I need to find the same Fibonacci number. Same number, finding multiple times. Now this is very much time consuming, like, okay, and it's storing your complexity also by time, by space. You need to find that same number every time when you reach the particular number, and now that is not feasible. Okay, it is very time consuming, so your time complexity increases by exponential. So there we will introduce the feature of dp. There we will use the feature of dp. Now once we find the result of third Fibonacci number, we will store it. So next time we will check if we have it already, like a cache. Okay, like a simple cache. We will see in our cache if I've already the number present in my cache. Okay, I'll take it from there. No need of finding it. So dp just stores the result of individual subproblems. It stores the results of individual subproblems. So this is when it's needed. Now we know that when to use dp. The main question is like, how we will know that we need to use dp? Mostly the point where you feel that recursion will be helpful, it mostly arrives to dp for time complexity and space complexity optimization part. Okay, you had the recursion solution in your mind, but you think that, can you optimize it better? You could think of dp. Now I could not say that every recursion problem will be solved by dp, no, but dp problems are related to recursion. That is true. That is true. Okay, so wherever there is overlapping sub problems for the Fibonacci, that is overlapping, right? 3 is coming to 3 times, 2 is coming again to 3 times. So mainly dp is used for overlapping sub problems where you need to find the sub problems so many times so that it is overlapping, so then you can store the sub problems which you have already find out. Cool. Now there are two techniques under the dp. Okay, one is memoization, which is also called as top down approach, and another is tabulation, which is called as bottom up approach. Okay, now what does this two means? This follows recursive method, this follows iterative method. There is no further space optimization or time optimization you can do. For the tabulation approach, you can still do space optimization under this. Okay, so now, um, as per me, recursive or memoization approach will be easy to implement first, and then from the recursion or memoization approach, you can transfer to the tabulation approach via seeing the steps and looking to the code of the recursion. You can easily create the tabulation code, and that is quite easy. But let's just first see. Sort of what are the steps you need to follow on or how to solve these problems. Okay, so let me just briefly explain how to solve DP problems, and then I can share the template with you all. Okay. Okay. So step one, decide number of changing variables. Okay. Decide number of changing variables and type of DP. So if there is a one variable changing, it's linear DP. If two variables changing, it's 2D DP. Okay. And if it's something related to interval kind of thing, then it's an interval kind of DP. So just decide a number of changing variables which you need in the whole problem, and then decide the type of the DP to use. Now step two. Step two says that define variables for changing states, like I equal to, so let's say my I is the index of the array. Okay. N is the count, let's say, which I'm storing in the DPs. Okay. So this I, J, N, K, whatever variables you are defining, you should know that what does this mean in your DP state. Okay. Now the third step, find base condition. Okay, this is the most important step. You need to find the base condition because you have to stop your recursion loop. Otherwise, it will go and go and go until endlessly. Okay, infinity times. And now step four says make DP state. Okay, make DP state and initialize it with -1. So initially all DP of i's should be equal to -1. Okay, ij or whatever is your DP state. Now step five, define what does it mean by DPI or DPI comma j. So whatever is your DP state, define like what does this mean? What is the DP of I? Let's say in Fibonacci is the DP of I represents the ith Fibonacci number. So this is I'm defining my DP state, like okay, what does it mean? My DP of I, what does it carry? What does it mean? Now is step six. If DP already has that state, then return it. Okay, so this is your overlapping sub problem. So if you have already find out the third Fibonacci number, so your DP of 3 is already filled. Okay, you just need to return that state. No need of finding it again. So if DP of I is -1, then only you need to go and find it. Otherwise, you didn't need to find it. Cool. And your step 7, do recursion for solving sub problem. Okay, whatever is your sub problem, do the recursion of that, or I could say uh, find all possible conditions, find all possible next states from current state. So let's say I'm currently in my ith state, wherever I can go with this I state in my hand. So that all you need to find. Okay. Now my step 8 is, while returning final answer, store it in DP and then return it. Okay, so this way you are storing your subproblem's answer in your DP. Store it in DP and then return. Okay, I hope you got. Now each step I'll go through until one or two videos where we will try to solve the easy level of questions of the linear DP. Cool. So the first thing is what you need to do is whenever we are initializing DP, let's say it's 1D, as of now we are going for linear DP. So there is only one variable changing. It's a single DP, 1D DP. So I'm initializing it with max n value possible. Now you can do it under your function which is given to you. whether you're solving in any of the editor. So whatever is your function you have to follow, let's say Fibonacci, then you can initialize this under that also. But the optimal way, or the cool way, or the most used way is this, where people used to mention the int dp of n. Let's say your n is maximum 1e5, then you make 1e5 plus 5 of array on the top as the global variable itself. So no need of passing it every time in your functions, okay, in your recursions. So that hectic will get be resolved. Now, second thing, you need to find, now you have this Fibonacci. Let's say Fibonacci we are solving. So you have int I, okay, only one variable, which is I need to find the ith variable. So first initialize what your dp of I mean. My dp of I mean, let's say here my dp of I mean ith Fibonacci number. So my dp of I stores ith Fibonacci number. Now I need to find the nth Fibonacci number. So whenever I'll call this Fibonacci number, what I'll do, Fibonacci of n I'll do, and I'll return that. Because I wanted to find the nth Fibonacci number, I'll return Fibonacci of n. Okay. Okay. Now, now here lies your base conditions. So if I is less than equal to 2, so for first Fibonacci number is 1, second Fibonacci number is also 1, we'll return 1, because first and second both Fibonacci numbers are 1 1. Okay. Oh, it's 0 1, sorry. So if I is equal to 1, or if I is less than equal to 2, we'll return I minus 1 if it's 0 1. Okay. Now it depends on the question given to you, like what are they expecting for 0 and what are they expecting for 1. Okay, this you can change depending on questions. So this is your base condition. So if my I goes below this level, I need to return I minus 1, because that part I know. Now lies your recursion part. Now lies your dp state part. So if dp of I is not equal to minus 1, then no need of finding it. Just return dp of I from here. Okay. And now you could go for two possible cases. Okay. Now that could be I minus 1 plus I minus 2. So I'm currently initializing one variable. So let's say current value is equal to dp of I minus 1 plus I minus 2 karke. And now what I do, while returning, I'll store it. So I'll return dp of I, which is what? This current value. So I'm returning and I'm storing it, doing it both ways. Okay. And now your main function, what does it do? Now you have initialized your dp array as a global variable, dp of n. So you need to initialize it with the minus 1. So always memset is a function to initialize your array with any particular number you want. So memset, what I want my dp variable to be minus 1 with full size of dp variable. Okay. So whatever is the size I have allocated on the top. And then I'll call this Fibonacci number for nth and I'll return it. Cool. Now the same thing happens with the tabulation. Now let's say I'm not doing this recursive approach. Then what I'll do? I'll make a dp of n size only. Okay. I'll initialize dp of 0 and 1 as, let's say 1 or 1 and 1. Okay. dp of 0 and 1 is, let's say 1 1. Or sorry, 1 and 2 is 1 1. dp of 1 is 1, 2 is 1. Now I'll run one for loop for I is equal to 3 to I less than n, less than equal to n. Okay, and what I'll do, dp of I is nothing but dp of I minus 1 plus I minus 2. And this will be run for until n times. So I'll return my dp of n as my final answer. Now, how can I do space optimization here? I know everyone had knowledge about this Fibonacci numbers, so I'm going it little fast. Now, how you could optimize this? You could store these two variables into, let's say this is previous 1 and this is previous 2. So I could make two variables over here as previous 1 and previous 2. Okay, so my current is previous 1 plus previous 2. Next time, my previous 1 will be previous 2 and my previous 1 will be my previous 2 will be previous 1 and my previous 1 will be current. So only two variables needs to be stored. No need of making full dp array of size n. Okay, that is not needed. I hope you got my answer. I hope you got this very clearly. Okay, without wasting time, let's just solve this problem so you get a better idea. But this session is actually about introductory on DP and specifically linear DP. So here it was mentioned, you could see that F0 is 1 and F1 is 1. Okay. I'll try to do it with the space optimization way only, but you could try it recursive tabulation and then space optimization. Okay. Okay. So uh, I could make two variables. So let's say previous 2 is 0 for me and previous 1 is 1 for me. Now I'm trying to do for I is equal to 2 till I less than equal to n, because I need to find for nth variable. Okay. So I is equal to 2 till I less than n and I plus plus. What I will do? What I will do? This many times I will do current is equal to previous 2 plus previous 1. I'll make my previous 2 as my previous 1 and previous 1 as my current. And finally, whatever is my current, that is my answer. So I'll return that current variable. So whatever is my current, that will be my answer. That is for the last time, nth time. Okay, cool. Oh, I need to initialize current also. So I'm making current as previous 1. Okay, because initially it's previous 1. You could make it 0 also, but still. Okay. Now they have given that n could be 0 and could be 30. Okay. So if n is 0, return 0. If n is 1, return 1. Otherwise, only go into these things. Okay. I would fail to this edge cases maybe. Cool. So this is the most optimized way, space optimized way. And this is a simple question where we are storing these two variables and using it for the next time. Okay, you can do it recursive way, tabulation way. In the next video we could see more questions and you will get a better idea. I need to tell so many things about what to define in the solve, how to do it, what is the difference between recursive and tabulation, but that all will cover in the next video. Don't worry if you didn't get any idea, this is just a theory. I'll try to do the questions in the next video and then we can relate it with this theory again. Okay, stay tuned, stay safe until then. Bye bye. Do like, share, and subscribe if you have learned a lot out of this.